All right. So today the standards we're looking at is represent and organize data using dot plots, histograms, and box plots. Okay. And analyzing data represented in plots and histograms. So how do we read the data that we're given? So what a dot plot is, it's similar to a bar graph. Okay, but instead of having a bar where you have to look over and try and figure out how high the bar goes, you just count the number of dots. The number of dots represents the frequency of the event. Frequency is how often an event occurs. So if they give us this dot plot here, okay, it's the number of pets. So what you're going to do is, let's say they might actually, usually they give you some background on the problem. So in a, in a certain school class, or a survey was taken out of a, group of people, uh, some group of people, and they'll say, ask how many pets do each of you own? Okay, so if I were to look at this, how many people own 5 pets? Take a look at this and see if you can determine how many people own 5 pets out of whatever that group was. Okay, so you go over here and you look at number of pets. This is the number of pets, 5 pets, and the frequency is 3. Okay, so that could be 3 individuals, 3 households. They could say each dot represents 100 people if it's a bigger group. Instead of having to put, 300 dots there, they could group each of those dots based off of the number of people, or 10 people, or something like that. Just, you have to read what they tell you that each of these dots represents. Like a problem like this, they'd have to give you some more information about it. Okay? So this would allow me to figure out, how many people own 2 pets, so we can count it. The other thing we're going to have to be able to do eventually, not right now, but next class, is figure out, okay, well, what is the average number of pets? Okay, or what is the mean? Average and mean are the same thing. Or they could ask the median. All right, so those are measures that allow us to represent data and give, has everybody heard of mean? The mean household income, or median household income. Mean is the average. Median is the middle. And we'll talk about which ones are better, used for different sets of data. Is it better to use the average, or is it better to use the median? Okay? So, example 1, how do we read the data represented in the dot plots? So you count the number of dots. To determine the frequency, or the number of times it occurs. Or the number of people, in this case, would probably be the number of people that have that number of pets. So this would probably be the number of times it occurs, or the number of people that have the given number of pets. Like I said, they didn't give us enough data to determine, is that one dot represent one person? Does it represent, every dot is 10 people? Something like that. So generally when we write these out, you're going to have some more information. All right, so create a dot plot of the following data. So what we need to do is, first thing we need to do is actually organize our number. So we got to look at this data and say, okay, what's the smallest, in this case, wind speed we have? They're all double digits, so 10 is the smallest, right? Now, generally on a dot plot, we put individual numbers. You could make a dot plot that had a range of numbers if you wanted. If there was, a big data set that, say, went 10 up to 100, instead of trying to put 90 numbers on there, you could go like 10 to, and you could group them if you wanted. But this isn't big enough to necessitate that. So what's the highest number it's got to go up to? 20. So I'm just going to go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I can go up, I can get all my data on there without having to make them smaller or group certain intervals together, make intervals. So 10. So the dot plots are easy because then you just go through and say, okay, well, I got 110. And then just count the number of 10s you have every time you have one, or you could just go right down the data if you're about skipping them. Go to 12. Okay, so I got one at 12. 15, I got one at 15. Another one back at 10. 17, another one. 20. 13. 10. Do some organization so you know which ones you've accounted for, which one you haven't. Might be better to make just like a little dot next to it so you can see that. Oh, got that one. Okay. 17. Instead of crossing them off in case you need the numbers later, start crossing them off. Then 19. 20. Another 10. 15. Another 10. 19. 16. 18. 11. So, like, what can we get out of this graph? When you look at this graph, what do you notice? Anybody have any observations about this graph? 10 has the most. Yep, definitely 10 has the most. No 14s. Yep. Yep, 10 to 20 is the range. That's a good observation. Okay, all the wins were in the interval from 10 to 20. Now the other thing you should probably put down here is label it. What are these? These are the what? Wind speed in knots. Make sure you label things. So wind speed in knots. Okay, those are all good observations that you can make out of this. Okay? Like I said, later we're going to be able to determine, we're going to talk about how do you find the average wind speed given the data, how do you find the median wind speed, things like that. All right, a histogram. Keys on a histogram. Make sure you label the interval and the frequency, the interval axis and the frequency axis. Generally, the interval axis is your horizontal, and the frequency is vertical. Okay, you can flip them around, but generally, usually they do it a bar graph where the bars go up. You could do a bar graph where the bar graph goes left to right. Okay, but generally that's how it is. Provide a title. What is this data representing? Okay. Okay, what a histogram tells us is it's a representation of a frequency distribution. That means of rectangles whose widths represent intervals. So now, these are going to be some interval. The last histogram we just did one data point, like 10 miles an hour. Right, it was one. Now you're going to get a range, possibly. There are some histograms that only have one instead of intervals, or you could do dot plots that have intervals, but generally if you're going to do an interval, you're going to do a histogram. Okay? So intervals can never overlap. So I can't go from 10 to 15 and then 15 to 20. Because what would happen if you had 15 in your data? You would have represented it what? 2 different times, right? You can't overlap. Intervals must be of equal size to make your data well organized. You can't do an interval for 2 units and then an interval for 10 units, because then you're not comparing apples to apples. The number of intervals, so how many intervals you have along the bottom, how many of these bars you have, should be between 5 and 15. Okay? So when you do a histogram, so for this one, these are the intervals, and this is the number of students. Okay, we're also going to do one where we do a percentage as well. Okay, we'll talk about that one later. So state the number of students for each score interval. So from 50 to 59. How many students were there? So just look right now and we'll talk about it in just a second. Don't say anything. Take a look and then we'll talk about it. Try these on your own. So, from 50 to 59, what did we come up with? How many students scored from 50 to 59? Yeah, I would say 8, right? This is smaller, the distance between there and 10 is smaller than the distance between, so it looks like about 8. Yep, so 8. What about 60 to 69? Yeah, if I go straight across here, that would be 5. Marking these up can't hurt, okay, so if you're not for sure. What about 70 to 79? I would say about 17, yep, I would say 17. 80 to 89? 14, just below 15. Okay, and then 90 to 99? 6, yep, it looks a little bit bigger than 5. 5 was here, if I take that line across. This is where a straight edge might help too, like putting a piece of paper or something down and going straight across from 5 so you can kind of see, okay, where you're at. So 6. So now, what is the total number of students who took the test? So how can I figure that out? Yeah, add these all up. It'll be 8 plus 5 plus 17 plus 14 plus 6. Let's see. Well, 8 plus 17 is 25. 25 plus 5 is 30. And 14 and 6 is 20. 30 and 20 is 50. Okay. Now we're going to make our own histogram. You have to be careful when you count these. This is where the biggest mistakes are made. Okay, they don't end up with the same interval size. So if you need to, count them out, right? So they tell us create a histogram of the following data, use interval size of 2. So we're going to start with our frequency table. So this will allow me to organize my data a little easier rather than going right to the graph. So when I do this frequency table, first thing I'm going to do is come up with my intervals. So look at the data and say, okay, my data goes from what to what? 0 to 12, right? So if I want an interval size of 2, what's my first interval going to be? This is where people mess up. 0 and what? Careful. 0 and 2 would be how many? 0, 1, 2, that would be 3, right? So I want my interval size to be 2. I have to include 0 as a number and then 1. Okay? What's the next one going to be? 2 to 3. Then the next one's going to be what? 4 to 5. And the next one's going to be what? 6 to 7. And the next one's going to be what? 8 to 9. Then 10 to 11. And then what? 12 to 13. Even though we don't have 13, we're still going to include that. So we keep our interval size consistent. So now, to make my frequency table, the reason why I do this is so I can just go through and make tick marks. So 4, put a tick mark there. 0, make a tick mark there. Instead of trying to count and missing them, this is an easier way to organize your data. 4, put a tick mark. 12, tick mark. 1, put a tick mark. 2, tick mark. 10, put a tick mark. 0, put a tick mark. Okay? This makes sense? Now, they didn't give us a whole lot of explanation what this would be. I'm assuming this is people, how many phone calls people make per day. So along this line is we're putting whatever these are, 0 to 13. What does the 0 to 13 represent? These are the number of phone calls per day. Up on my vertical, this is usually going to be the number of people. And then the title for this would be the number of phone calls per day that people make. Now, if you knew more info about this in, Mrs. Johnson's class or whatever it would be, then you'd put that in there. Okay? So I don't know that specific information, so number of phone calls per day. Like I said, if you knew more information about it, you could say made by, people surveyed at the mall or in Mr. Seal's class or whatever. Okay, that's where you put your title. All right, so now I need, how many intervals am I going to need then? 1, 2, 3, 4, 5, 6, 7. So I need 7 intervals here. So I got to divide this line equally among 7. So 1, 2, 3, 4, 5, 6, and then 7. That'll be my last one. Okay? So now we got to label each of those intervals. So this first interval is what? 0 to 1, 2 to 3, 5, 6 to 7, 8 to 9, 10 to 11, 12 to 13. So if you understand why we didn't go like 0 to 1, then 1 to 2, right? Because if you did that, 1 is actually a data point. That would fall in 2 different intervals, which would skew our data. Okay, and then now my highest frequency is 4. Okay, so I'm going to divide this. I'm going to label these. Okay, I don't need ranges here like the last one we looked at because we know. You can just do 1, 2, 3, 4. If it was 40, you know, if it was like 40, I probably wouldn't put 1 to 40 on there. I would probably put some interval there too, right? So like, you know, 1 to 10, 11 to so on and so forth. Usually I'd go. All right, so from 0 to 1, what's my frequency here? 3. So when I make my graph, I'm going to make a box. Goes like that. Now, if you want, you can shade it. You don't have to. Sometimes shading a little differently kind of helps see what it looks like better. Using maybe different colors, different shadings, etc. So if you only have one color, maybe shade them a little differently. So, 2 to 3, how many people was that? 2. Like I said, if I don't have a different color, then I'm going to shade maybe a different direction, or so you can see the differences between the bars. 4 to 5. Go all the way up to 4 on that one, right? Six to 7. 2. 8 to 9. 10 to 11. 2. And 12 to 13. Okay? Okay? So that's how you make a frequency table. And then a histogram. So this is your frequency table right here. This is your histogram. That's the bar graph that represents that frequency table. Okay? What questions do we have on that? It's not hard work. It takes a little bit of time, but it's not hard. Okay? All right, a relative frequency histogram. The only difference between a histogram and a relative frequency histogram is that now instead of having a number over here, you're going to have a percentage. Notice this is a percentage. So what a relative frequency is Okay, is the frequency of an interval divided by the total number of values, meaning you're finding the percentage. Instead of saying there's 4 students, you're going to find out what percentage of the total is that 4 students. Okay? Relative frequency histogram is now you, on your vertical axis, you put a percentage. Instead of like the number of students, you say the percentage of students. So when you add up all your percentages, you should come up with 100% for each interval. Okay, so can you say, what can we conclude from this information? So how do we interpret this graph then? So what can we say? Give me your observations about this graph. Yeah, the highest percentage of students scored from 70 to 79 for the most the students scored, right? The highest percentage. Any other observations? Any other observations about this? So the smallest group of the smallest number of students scored 60 to 69, right? Okay, good. All things you can conclude from this, right? These are just your basic observations. Looks like there's more students skewed towards the middle and the upper end than the lower end, right? Which is good if you're giving a test. So is it true that 50% of the students scored an 80% or higher? If not, what percentage did? So what we can do is we can figure out by looking at it. Okay, this looks like about what percentage from 80 to 89? That'd be what? Yeah, 27, 28, probably more like 28. I'd say about 28%. Okay, what percentage? We want 80% or higher. What percentage scored 90 to 99%? This is where having a straight edge or something might be helpful. I'm going to draw this across, kind of give me a idea there. So 10 would be right there. So what does that look like? How does that relate to 10 then? It's like about 12, right? Now, this is where when you're making these graphs, sometimes you can adjust the transparency on the bars. It might help readers more easily, reviewers more easily see it if you can adjust the transparency on the bars so you can see the grid lines behind it. Okay, so this would be about 12%. So is it true that 50% of the students scored an 80% or higher? No. What percentage did? About 40%. So the next one, did a majority of the students score at least, we should say at least a 70%? So this would be what? 34%. Right? So is that 70% or higher? Is that a majority? So 40 and 34 is 74%. So I'd say, yeah, the majority, right? About 74% did. Okay. So now we're going to make a relative frequency histogram. So the age at which 20 people got their first car. So generally you can take that the age at which got the first car. So down here we're going to put age. And then you should usually put your units if it's not obvious. Usually ages in years, but you know, if it's something like you're not for sure of length of something, make sure you put whatever units of measure they're talking about. You know, if they're talking about miles versus kilometers, it makes a difference, right? So the more information you can give, the better off. Okay, and this is a relative frequency, so we're going to do percentage of people going up. Leave some room so you can label when you, or put your units down when you label these. Okay, I like to do it right away because that's the one thing a lot of people forget. All right, so it says use class intervals of 3 starting at 16. So this is where counting helps. Okay? So if I have an interval of 3, what's my first interval? If I start at 16, it's going to be 16 to what? 16, 17, 18. A lot of people think, well, that's 2. Well, the difference between them is 2, but when you're talking about data, 16 is a entry point, 17 and 18 are all, so there's 3 in there. 16 to 18 is 16, 17, 18. So the next one's going to be what? 19, 20, 21. Next one's going to be what? 22, 23, 24. The next one's going to be what? 25, 26, 27. Next one's going to be what? 28, 29, 30. Yeah? So I can go put that on. So I have how many? 1, 2, 3, 4, 5 different intervals here. So first interval is going to be 16 to 18. Next one's going to be 19 to 21. 22 to 24. 25 to 27. 28 to 30. Now, I'm not going to put my percentages on until I know what my percentages are going to look like here. So I want to know what I want to count by here. All right. So let's find out our frequency. You need to know that to be able to find your relative frequency. So 17. So put 1 there. 27, 21, 18, 16, 23, 5, 19, 20, 21, 30, 2, 19, 19, 21, 16, 18, 16, 22, okay, so this is how many. This is the frequency. Now, relative means you're relating it to everybody else. That's where your percentage comes into play. Okay, what percentage of the whole? If you just put the number, that's, the frequency, that doesn't relate it to the whole. But when you find a percentage, you can figure out what it is related to the whole. So, how do I figure out my percentage for the interval from 16 to 18? How do you find a percentage? Yep, you take how many divided by the total. Well, they said there's 20 people in this data set. If they don't tell you, you got to count them up. Okay, so you take what this interval is divided by the whole. So 6 divided by 20. Okay, then that'll tell me my decimal, then I multiply by 100. So, if you need to reduce it to tenths, and then it's easy. So how many tenths would this be if you don't have a calculator? 3/10, which is what percentage? 30%. The next one's going to be what? 8/20. So that's how many tenths? 4/10, which is what? 40%. Next one's what? 3/20. Now what you can do is you can divide by 2 and you might get a decimal, but then that'll tell you that it's what? This would be what, 1.5 tenths? So what percentage is that? 15%. Okay. The other thing you could do is you want it out of 100, so you could multiply the top and bottom, because this is out of 20. You could get the fraction to be out of 100. That's another way you could do it. You can multiply the top and bottom here, 20 times 5. So you're going to multiply everything by 5. So this would be 30 hundredths, this would be 40 hundredths, this would be 15 hundredths. Okay, so you can multiply the top and bottom by 5 to get as long as you can get the bottom in terms of 100. Okay, this would be 2/20, which is 1/10, which would be what percentage? 10%. And this would be 1/20, which would be what? 0.5 to 10, which is 5%. Okay, or like I said, you could do 1/20, and you gotta get it over 100, so you multiply by 5 over 5, so it'd be 5 over 100, so 5%. It's another way you can do it. You don't have to calculate. All right, so now, what do we want to count by going up here? What do we want my intervals to be up here, probably? Count by 5s? You count by fives, yep. You do 5%, 10%, 15%. Ah. So 5%, 10%. Now, you don't necessarily have to label all of them. What I might do is do this to make it a little neater. Count by fives, but only label like the tens. So 10, 20, 30, 40. Okay? So nothing says you have to label every one. As long as you make the intervals the same, okay, then you're good to go. All right, so for 16 to 18, I need to go where? 16 to 18 is up to what? 30%. Throw that in. A bit. 19 to 21 is at what? 40%. So I'm going to take this up. 40. Uh, 22 to 24. 15%. All right. So come across here. $25 to 27. 10%. There. I got a little high up there. Said if you have a straight edge, it might be nice to use. Okay, and then 22 or 28 to 30. 5%. Right. So, you have to make sure you read. Do they want a histogram or do they want a relative frequency histogram? So histogram is just the number of data entries. Okay, like the last one. A relative frequency histogram means you have to turn them into percentages. Okay? Splats another time. Alright, so let's try some of these. So let's look at stats practice 1. We are going to go to problem number 4 on this and do this first. Okay? So create a dot plot, create a frequency and relative frequency table. Tells us the intervals. And create a relative frequency histogram. Now, D and E, we're going to do those. We'll come back and revisit those because we haven't talked about median or mode yet. All right. So, first thing we're going to do is create a dot plot. So the dot plot you can kind of come up with on your own. This is a set of data. Shoot, I don't like that it doesn't tell us what it is because then we can't label. All right. Anybody have a creative label for this? So the lowest is what? 16. The highest is 49. I don't know. We already did buy a car. Age at which you bought the car. 49 seems a little bit old. Some data set where it goes from 16 to 49. Let's say, all right, someone's come up with something. So we had a volunteer boxes of cookies sold. All right, so create a dot plot. So I need to go from 16 to 49, huh? That's quite a bit. On a dot plot, you don't necessarily have to account for all of them, because this is just talking about frequency. So you could probably just put all the data pieces down here, and if there's missing, it's not going to matter as much. So we can start with, our smallest one is at what? 16. Now the hard part about this is trying to make sure you get them all. So 16 would be 1. What's the next one going to be? 16, I see 17, right? How many am I going to have at 17? This is where if you don't have the intervals, it's kind of tricky, because if you miss one, then you got to try and wedge it in there somewhere. So 16, I got 1. 17, I have 3. The next one in line order is what? 18. 18, I have 1. Do I have any 19s? Nope. 20. 20. 21. 21. 22. Nope. 23. Let's see, 1. 2 23s. Yep, there's the third one. 24. 24. 25, I saw 1 or 2, or at least 1, 2, 3, 4. 4 25s, right? I have a 26. More, nope. 27, no. 28, no. I'm no more 20s. So the next one's at 30, right? 30. 31, no. 32, no. All the way up to what? 38's the next one. And I have a 39. 2 40s. A 41. And then lastly a 49. She labeled boxes of cookies sold. Okay. Extra O in there. Okay. All right. Create a frequency and relative frequency table. So, I need intervals. Start with 15 and use intervals of 5. So my intervals, starting with 15. So if I start with 15, what is my first interval going to be then? So this is going to be my interval. This is your frequency. This is going to be your relative frequency. So my first interval is going to be what? Yeah, 15 to 19, because you have to include 15, right? 15, 16, 17, 18, 19. 15 to 19. So then what's the next interval? 20 to 24. What's the next interval? 25 to 29. What's the next interval? 30 to 34. Remember, 30 to 34, it's only 4 units apart, but that's how many data points? 30, 31, 32, 33, 34. That's 5 data points. We have to go all the way up to 49, right? So the next one's going to be 35 to 39. The next one is going to be 40 to 44. And then the last one's going to be what? 45 to 49. Now, you can use your dot plot to figure out your frequency, right? It's already kind of organized for you, if you have one. If not, you just go up and count them, right? Do like we did before, just every time you find one, make a tick mark. So 15 to 19 would be, if I had my dot plot done, I could just count them. So what's 15 to 19? Well, I have 1, 2, 3, 4, 5, right? '20 to 24. So that would be what? 20, 21, 23. That's another 5. 25 to 29. That's another 5. 30 to 34. That's what? That's 1. 35 to 39. 2. 38 and 39. Okay. 40 to 44. 3. And then 45 to 49. 1. Now, one thing that's helpful when you have your frequency table, to find your total, to do your relative frequency, you can add them up, right? It'll be 5 plus 5 plus 5 is 15, 16, 18, 21, 24. Right, so your total is 24. Or you could have counted the original data points, however you want to do it. You got to find the total to be able to do the relative frequency. All right, so this is going to be 5 out of 24. No, that one's not going to be a nice, neat, easy way to get it. So this one you're going to need percentages, so you're going to have to go to your calculator. So you do 5 divided by 24, and then multiply by 100 if you want the percentages. 5 divided by 24 times 100%. Is it? 15, 16, 18. 18 and 4 is 22. Oh, you're right. 22. Can't count. Sorry, 22. All right, it is 22. All right, good catch. So it's 5 divided by 22 times 100. That's going to be 22.73%. So that's going to be the same for all of these. One divided by 22 times 100. So it's going to be 4.54, or 4.55 actually, round. All right, next one is going to be 2 out of 22 times 100. So it's going to be double that. 9.09. Three out of 22 times 100. It's going to be 13.64. And we already did 1 out of 4.55%. All right, so before we make our, all right, so when they give you these problems, you have to, first thing, once we get done with this, we need to look at what kind of a histogram do I want? Well, this is a relative frequency histogram, so this is where I'm going to have the percentages. So now, if they didn't ask for it up here, if they don't ask you to make a relative frequency table, they just say a frequency table, then you're just going to make a regular histogram where you put the number of occurrences on the vertical. Okay, this is a relative, so you're going to put the percentage on the vertical. Okay, so how many intervals do I need? 1, 2. I'm going to need 1, 2, 3, 4, 5, 6, 7 intervals. From 15 all the way up to 49. Okay. 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, and 45 to 49. Okay. Now, what should we count by going up? Let's see. The highest I need to go to is 22.73. So I'll probably count by fives, right? Pretty evenly spaced. All right, so now we got to label our axes. What is this down here? Boxes of cookies sold, right? That's percentage of people who sold that many. Okay, so this would be the boxes of cookies sold for 22 whatever people, Girl Scouts, whatever. That was their total number, right? Troops, I don't know, whatever. All right. So now from 15 to 20 or 15 to 19, I'm where? 22.73. Twenty-four to 20 or 20 to 24. Same thing, right? Twenty-five to 29. Dang. That one I might just leave blank. Okay, I got the rest of them shaded. I'll leave that one blank. Don't really want to. You could come up with some other distinguishing marks. You can tell the difference between them. Okay, then 30 to 34. That's 4.55. Just below 5%. Uh, 35 to 39. 9 point. Just below 10%. And then 40 to 44, we're at 13 point. then 45 to 49. Okay. What questions do we have on that? So we did dot plots. These don't necessarily, you don't have to include every single one here. Frequency table, you have to come up, make sure your intervals are consistent. Exactly the same, make sure none of them overlap. Okay, a frequency table is just the number. A relative frequency table is the percentage. Same thing for our histograms. A histogram would be just the number up here. Okay, versus a relative frequency histogram, which is the percentage. Okay, everybody know the difference when to give what, which one, depending upon what they ask for? Okay, make sure you read what they're asking for.